Okay, guys, Chapter P, Section 5, Part C. We only have one more section after this, and then we're done with our prerequisites, so that's good. We're going to add and subtract rational expressions. Yesterday, we did multiplication and division. Did you need to get a common denominator when you multiply and divide? No. Do you need a common denominator when you add and subtract? Yes. Okay. Rational, just a grown-up way to say fraction, so let's talk about this. When you add and subtract, guys, you have to have a common denominator. That is paramount. You cannot add and subtract unless you have a common denominator. We must factor the denominators first. Every single time that you can factor denominator, you need to do that first. And that will help us find our least common denominator. All right, our least common denominator, which you guys are all familiar with. Then we're going to multiply each term by what is missing from our common denominator, add, subtract numerators, and there we go. You're always going to simplify at the end. So if something factors, once you have combined like terms and all that, we're going to simplify. What I want you guys to remember, all right, the first two questions, hopefully, are super familiar to you. But I want you to do them in this way because this is the way you're going to do it with a rational expression. I know everyone in here can tell me what the common denominator is between 2 and 3. What is it? 6. But do you guys agree with me that 2 and 3 are completely different numbers, right? So how do we get a common denominator? How did you arrive at the common denominator of 6? What'd you do to 2 and 3? You multiplied. So I'm just going to write them down independently on the bottom here because we're going to follow this process. And then I'm going to look at my first fraction. In order for my common denominator to happen, my first fraction has a 2. What do I need to multiply the 2 by to make it the same as the one in blue? I have to multiply by 3, correct? Well, what you do to the bottom, you do where? To the top. So I have 3 times 1 is 3. My second fraction, it already has the 3. What is it missing? The 2. So I'm going to multiply the bottom by 2. When I multiply the bottom by 2, I do it to the top. So 2 times 1 is 2. And now we simplify. What is 3 plus 2? 5. And we can go ahead and multiply 2 times 3 is 6. I know that's super basic and that's a long way to go about that, but that's the thought process you need to have. All right, let's look at the next one. What's my common denominator between 6 and 12? 12. All right, I know you guys all know that, but how's another way I could write 12? I could write it as 2 times 6, right? So if you're going to tell me what my common denominator is, you guys told me it's 12, which is 2 times 6, correct? Well, my first fraction already has the 6 in the denominator. What's it missing? The times 2, right? So what you do to the bottom, you do to the top. So 2 times 1 is 2. My second fraction already has the 2 times the 6, so I just leave the numerator alone. And then I simplify. What is 2 plus 1? 3 over 12. Do we ever leave a fraction unsimplified? No. What is 3 over 12? 1/4, okay? I'm not kidding you guys. The next examples that we do are just as simple as that. If you guys think very basic numerically, you'll understand why I just did what I just did. Look at number 3. What do you notice about the denominators? They are the same. Guys, are you allowed to just go like this? No, do not do that. That's against the law. I was looking at some of your homeworks last night, and somebody, there was an error analysis, and it said what happened, and somebody wrote, that's against the law to cancel like that. I was like, oh, somebody's listening. But when you have a common denominator, do you have to do anything to the denominators to combine them? No, I'm just going to rewrite my denominator one time, and I'm going to put it in parentheses so I remember, hey, that x is stuck to the plus 1. And then you combine like terms. What's 1 plus 2? 3. Can you simplify anything? Is anything on the bottom and the top exactly the same? No. So there's your answer. What do you notice about the denominators here? They are the same. So we just rewrite it one time. How is this problem, number 3, a little bit different from, 4, a little bit different from 3? It's subtraction. you don't have to do this. This is just my suggestion. Anytime I have subtraction, I like to put parentheses around my binomials. And then I like to change this sign to a plus. And I like to stick the subtraction sign right there, because what do I have to do with that subtraction sign? I have to distribute it. That's where you guys are going to make mistakes here. You'll be fine with getting a common denominator, but when it's a subtraction, you'll forget to distribute the negative, and then your numerator is going to be wrong, because this ends up being x plus 1. What? Minus 2x, then what? Plus 3. If you forget to distribute, you're going to get the answer wrong. So you got to just pay attention to that. And now we're going to combine like terms. I'm going to rewrite my denominator of x plus 2. When I have a positive x and a negative 2x, what does that give me? Negative x. And then I have 1 plus 3 is 4. You can leave it like that. If you want to write it as 4 minus x, that's fine as well. If you wanted to write it like negative and then x minus 4, sure. Over x plus 2, sure. Same thing. No problem at all. All right, so let's move along here. I need a common denominator between x and 6x. What do you guys think it's going to be? 6x, good. So write down 6 and x. Look at your first fraction. Your first fraction has the x. What is it missing? So if I multiply the bottom by 6, then I have to multiply the top by 6, correct? God bless you. So I have 6 plus, do I have to do anything to this fraction? No, it already has the 6x, so 5. Simplify becomes 11 over 6x. Can you simplify anything there? God bless you. No. If that number was 12, could you simplify? Yes, okay. Just make sure we see that. All right, let's look at number 6. Is there anything to factor? No, right? All right, guys, look at these are two completely different denominators. This one has an x. This one has an x plus 1. So think about the first example we did. I had two completely different denominators. It was a 2 and a 3. And what did I do to them? I multiplied them. I stuck them together. So I'm going to do the same thing. I'm going to stick them together down here, an x and an x plus 1. And then I look at each fraction individually. My first fraction here already has the x in the denominator. What is it missing? X plus 1. Not just a plus 1, the whole thing of x plus 1. When you multiply the bottom by x plus 1, we then do what? Multiply the top by x plus 1. My second fraction has the x plus 1. What is it missing? So if I multiply the bottom by x, then I multiply the top by x. Notice now the denominators are all the same. There is a plus sign in the middle, so I don't have to worry about distributing anything negative. So I just have 1 times x is x. 1 times 1 is plus 1. And then 1 times x is x, correct? Now when we combine, what combines in my numerator? I have 2 x's plus 1. Put it in parentheses. And then on the bottom, I have x times x plus 1. Are any of your parentheses identical on the top and the bottom? No. So then leave it. You do not have to FOIL the bottom. You do not have to write x squared plus x. Do not do that. Leave it factored. Leave it separated. Okay? Survey the situation, guys. Put your parentheses around your denominators. What do you notice about the sign in the middle? It's a minus. I'm going to go ahead and change this to a plus and put a negative right here in front of the 3. You do not have to do that. I just do that so I don't forget to distribute the negative. Now, again, guys, we have two completely different denominators. So in order to get a common denominator, what do I do with those two completely different ones? I'm going to just multiply them. So I'm going to write x plus 2 and then x minus 4. There's nothing to factor there. You can't break those down at all, so that's all we got to do. So my first fraction, I look at it and I say, okay, it has the x plus 2 in the denominator. What is it missing? The x minus 4. So when I multiply the bottom by x minus 4, then I multiply the top by x minus 4. My second fraction has the x minus 4. What is it missing? The x plus 2. So if I multiply the bottom by x plus 2, then I multiply the top by x plus 2. So as we go to simplify, 1 times x is x. 1 times negative 4 is minus 4. And then remember, guys, you're distributing a what? A negative 3. So negative 3 times x is minus 3x. And negative 3 times 2 is negative 6. That's the biggest place for you guys to make a mistake, is you'll forget to distribute that negative. So now I'm going to rewrite my denominator. Just leave it as x plus 2, x minus 4. There's absolutely no reason for you to multiply it back together and combine like terms. What is x minus 3x? Negative 2x, good. And then what is a negative 4 and a negative 6? Negative 10. How would I like you guys to simplify this just a little bit more? Is there a GCF in the numerator? Yes. Go ahead and always take out the GCF, because you might end up where once you factor out the GCF, then one of your parentheses is the same on the top and the bottom. So you don't want to ever miss an easy simplifying point. So here I'm going to take out a negative 2. And what does that leave me with? X plus 5. Okay. Are any of your parentheses exactly the same? No. Do you have any numbers on the outside of the parentheses that can simplify? No. But always simplify as much as possible, because you might end up in a situation where when you factor out that GCF, a parenthesis in the top and the bottom are exactly the same. All right, let's look at number 8. Bunch of things to look at. First of all, is there anything to factor in the denominators? Can you simplify the denominators anymore? No. So I'm just going to go ahead and put them both in parentheses. And what do you notice about that sign in the middle? It's a minus. I'm going to go ahead and change it to a plus sign and then stick that negative right there, just so I don't forget that that's a negative 2. So guys, again, 2 completely different denominators. So what do? You just multiply them, you write them together. And then you figure out what each fraction has and what it's missing. So my first fraction already has an x minus 3 in its denominator. What is it missing? The 3x plus 4. What you do to the bottom, you do to the top. All right, my second fraction already has the 3x plus 4. What is it missing? The x minus 3. Great. So what you do to the bottom, you do to the top. And now we just algebra. What is x times 3x? Perfect. 3x squared. What is x times 4? Yep. What's a negative 2 times x? Negative 2x. And what's a negative 2 and a negative 3? Plus 6. So combine like terms are right here in the middle. What can you combine? What can you combine in the middle? 4x and negative 2x. What's 4x minus 2x? All right, so we're left with 3x squared plus 2x plus 6 over x minus 3, 3x plus 4. What do you think I need to check to see what will happen if my numerator factors? So let's just check. A times c. Factors of positive 18 that multiply to give me positive 18, but add to give me 2. 1 and 18? No. 2 and 9? No. 6 and 3? No. So is this going to factor anymore? No. So you're good. But sometimes they will, so always check. How you guys feeling? Okay? All right. Almost done. A couple more. All right. Let's look at number 9. Survey the situation. Is there anything in the denominator that can factor? No. So let's just go ahead and put both of our denominators in parentheses. I see a minus sign, so I'm going to go ahead and change that to a plus and stick the minus up here so I don't forget to distribute it. When you have 2 completely different denominators, how do we find the common denominator? You just multiply them together. So you're going to stick them together in the denominator and then figure out what your equivalent would be. Well, how can I make the first fraction have the same denominator? How can I make the second fraction have the same denominator? So I look at my first fraction. It already has the 2x minus 1. What is it missing? What's it missing? The x plus 2. So I'm going to multiply the bottom by x plus 2. Then I multiply the top by x plus 2. My second fraction has the x plus 2. What's it missing? What's it missing? The 2x minus 1. So when I multiply the bottom by 2x minus 1, then I multiply the top by 2x minus 1. And now all three fractions have the same denominator. So now let's just distribute. What's x times x? X squared. What's x times 2? 2x. What's negative 1 times 2x? Minus 2x. And what's negative 1 times negative 1? Plus 1. All right, so we rewrite our denominator. 2x minus 1, x plus 2. And then my numerator. I have x squared. What happens here with a positive 2x and a negative 2x? They cancel, and I have plus 1. Can I factor x squared plus 1? What are you going to factor it into, guys? X plus 1, x plus 1. When you multiply that together, you get x squared plus 2x plus 1. Is that the difference of squares? No. Yes, they're both squares, but is there a minus sign in the middle? No, so just leave it, just like that. It's not meant to be a trick question. All right, let's look at number 10. 2 more, and then we're done. Can I factor anything in this one? Oh, wait, you can. So let's go ahead and do that. Because remember, guys, we're trying to find the least common denominator. Not just any common denominator, the one that's the smallest. So if you put all of this together without factoring it, you're not going to get the least common. Hang on one second. All right, so we factor this. This is gone. So now this is a little bit different. This is kind of like the one that we did at the very beginning when we had 6 and 12, where one denominator had a piece of it already involved. You know what I mean? Like one had a 6 and one had a 12, which is like 2 6s, that sort of a thing. So look at what a common denominator would be here. What do they both already have? They already have an x plus 3. Perfect. And then what's the piece that one has that the other one doesn't? The x minus 3. Whenever you can factor and there's something in common, you write down the one that they have in common because it's already accounted for. Then you write down the one that's missing so we can make all of them have the same. So if I look at my first fraction and I want my denominators to look the same, aren't they already the same? Yeah, so is there anything I need to do to the 2? No. So look at the second fraction. It's x plus 3. What is it missing so it has the same? X minus 3. Good. What you do to the bottom, guys, you do where? Perfect. And since it's a plus sign in the middle, this really makes our life a little easier. So I have 2 plus, distribute. 4 times x is 4x. 4 times negative 3, minus 12. So now I have x plus 3, x minus 3. What can I combine on the top? 2 and negative 12, which gives me minus 10. And then can I factor a smidgen more? Yes. What can I take out of 4x and 10? 2. So I'm left with 2x minus 5 over x plus 3 and x minus 3. Anything exactly the same on the top and the bottom that I can cancel? No. So you guys are good. You guys try 11. What's the first thing you should do? Factor. Good. Try 11. All right, walk me through it. Walk me through. What's the first thing I need to do? Factor. What is x squared minus 1 going to factor into? X plus 1 and x minus 1. Good. Do I have any minus signs that I need to be mindful of? No. So common denominator. What's my common denominator going to be between x plus 1, x minus 1, and x plus 1, x minus 1? X plus 1 and x minus 1. Perfect. So now let's figure out what each fraction has and what it's missing. My first one has the x plus 1. What does it need? X minus 1. What you do to the bottom, guys, you do where? To the top. Good. Second fraction has the x minus 1. What does it need? The x plus 1. Perfect. So what you do to the bottom, you do to the top. And my last one already has both of them, right? So do I need to do anything? No. So let's just distribute. 2 times x is 2x. 2 times negative 1 is minus 2. Plus 2 times x is 2x. 2 times 1 is plus 2. And then I have plus 1. So when I combine like terms, what is 2x plus 2x? 4x. What's a negative 2 and a positive 2? Cancels. Good. So you're left with just plus 1. And then on the bottom, we have x plus 1, x minus 1. Is there anything that I can cancel? Anything on the top and bottom that is exactly the same? Nope. So you guys are good to go. So right now, all right, tomorrow we're going to work on this a little more because I know it's very easy as I go through it. I guide you on everything to do. I want you to try all of the homework problems. I think the evens are already posted with the solutions. So tomorrow in class, I will work out the ones that don't have the solutions so you can see them. If you guys want to wait, and I would like you to try some of them tonight. But tomorrow you will have time to work and ask questions and that sort of thing. We're also going to get your WebAssign account set up. So that'll be good. Sound good? Okay.